So the second topic is on force equation. I think you are familiar with the equation here. So force, or the net force, is equivalent to the product of the mass and the acceleration. So our basis for this is the second law of motion. So let's talk about some implication of the second law of motion, so that we can see the relationship between the three variables: the force, the mass, and the acceleration. So increasing the magnitude of the unbalanced force acting on an object will also increase its acceleration. So if you push more on a box, for example, it will accelerate more. So the more force you give, the higher will be the acceleration. So the relationship between the two is quite um, directly proportional, rather. Okay, let's take a look at the next implication. If the same unbalanced force is applied to two objects, the heavier object will experience lesser acceleration than the lighter object. Okay, so if you have two objects, one is heavier, another is lighter, and we are only able to give, we would be giving the same force on both of them. So mas mahirap i-accelerate yung mas mabigat kaysa doon sa mas magaan, right? So it would be harder to move um, a car compared with a tricycle on your own. Okay? So if you increase the mass of the object, the greater force you would also need to accelerate it. Or heavier objects are harder to accelerate. So going back to the equation, net force equals mass of times acceleration, we can derive this other equation if we are looking for the acceleration. So how did that came to be? Yeah, you will just divide mass on both sides, and you will be able to come up with the equation for acceleration. So going back to newtons as our unit for force, Newton is actually a combination of two units. So kilogram multiplied by meter per second squared. If you remember, kilogram is the unit for mass, and meter per second squared is the unit for acceleration. So if you multiply them together, you combine them together, what you get is newtons. Now, how will you get meter per second squared? By dividing newton by kilogram. Diba? Force over mass. Remember, Newton, if you break it down, is kilogram times meter per second squared. You can cancel the kilograms. Then you are left with meter per second squared, which is your unit for acceleration. Sige, let's solve some sample problems. If a 70 kilogram skater is acted upon by an unbalanced force of 161 Newton directed to the west, what is its acceleration? So we need to remember the formula, what to use. Acceleration is net force over mass, di ba? And we need to remember ano yung unit ng force, ano yung unit ng mass. Otherwise, we might confuse the two values here. So 161 Newton is our force, and 70 kilogram is our mass, obviously. So this is just a matter of dividing the two. Ano po? 161 divided 70 is 2.3. Newton, again, is kilogram times meter per second squared. You will get to cancel the kilograms, and you will be left with meter per second squared. So whatever the direction of the net force is, or the unbalanced force is, that is also the direction of your acceleration. Okay, that's just direct substitution. Ano po? Now, let's take a look at something less direct, if I may say so. A force of 360 Newton east was applied by a student on a box with a mass of 50 kilogram. What is the acceleration of the box if a frictional force of 340 Newton west acts in the opposite direction? So this box is 50 kilogram in mass, and then a force, an applied force is is acting on it. So it is directed to the east, to the right. So F applied force. Meanwhile, another force opposite the direction of the motion is acting on it. 340 Newton. This is my frictional force. Okay, just some information about frictional force. Frictional force is always against or opposite the direction of the motion. So if your applied force is causing it to move, frictional force is preventing it from moving. So even if hindi kasama ito, ano po in the question, hindi sinabi kung saan yung direction ng friction. Basta sinabi yung the direction of the applied force, you should already know that sa kabilang direction yung friction or the frictional force. Okay? So remember, when you push a box across a surface, yung surface and the bottom of the box at the atomic level, at the microscopic level, are interacting. That's thereby creating a frictional force. So we need to find the acceleration. Our formula is net force over mass. But we know the mass, but not the net force. But we can simply compute for that, since we are given with the two forces along the x. So you can see it here, the computation, 360 newtons takes the positive sign, while 340 takes the opposite sign. So magsusubtract ka pala dito. 360 minus 340 is 20 newton to the east. Okay? So now you can solve for it. The acceleration, net force is 20 newtons, mass is 50 kilograms. 20 divided 50 is 0.4. And Newton over kilogram is meter per second. This is to the east. Okay? Okay, we have another problem. Here now is a two-step problem. Ano po? And let's draw first an illustration. A box, a 10 kilogram box is being pushed by an applied force. Walang direction na binigay for the applied force. We can just assume that it is to the east. And no given value for the applied force this time. But we have an acceleration as well, 2.5 meter per second or meter per second square. What is the applied force? Okay, that's what we need to find out, the applied force. If a frictional force on the opposite side is acting also on the object, 50 newtons, frictional, we also don't know the net force. But we can solve for the net force, right? By multiplying the mass to the acceleration. So 10 times 25 or 2.5 is 25 kilogram times meter per second is newtons. So that's our net force. That's very useful, kasi if you know the net force and you know one of the forces acting on the object, we can also solve for the other missing force. So this is just from the previous slide, computation for the net force. So if ang lalabas na net force is 25 newtons and meron akong 50 dito sa kaliwa, ano yung force na dapat dito sa kanan? What should be the value of the applied force? Such that if deducted by 50, it will result to a net force of 25 newtons. So 75 divided 50 siguro, that will give me 25 newtons. So net force is equivalent to applied force minus frictional force. We can also solve it using algebra. Net force is 25 newtons. Applied force is unknown. Frictional force is 50 newtons. So the next step is to put this on the other side of the equation. Applied force is 50 newtons. Magiging positive na siya, plus 25 newtons. That's why we were able to come up with 75 newtons. Okay, let's solve this problem. What is the acceleration of a bowling ball with a mass of 50 kilogram? This is my mass. If the net force of 20 newton is acting on it, F net is 20. I need to solve for A. So my formula is net force over mass. Net force is 20 newtons. Mass is 50 kilogram. So 20 divided 50 is 0.4. Newton over kilogram is meter per second squared. The direction is not given. Let's just assume that it's moving to the east. Okay? Oh, this is not a two-step problem, by the way. Just a simple direct substitution problem. Okay. Now, into something more complex. What is the applied force needed on a 2 kilogram block of wood? We have a wood that is 2 kilogram, accelerating at 4 meter per second squared along a rough table with a 10 Newton force of friction. So let's say applied force is directed to the right. We don't know that, the value of that. So the frictional force we put to the other side. This is 10 Newton. This is the mass. Just like the other problem, we can first solve for the net force, mass times acceleration. So the mass is 2 kilogram. The acceleration is 4 meter per second squared. So 2 times 4 is 8. Kilogram times meter per second squared is newtons. So that's my net force, 8 newtons. Now, what should be the applied force if the frictional force on the opposite side is 10 newtons and the resulting net force is 8 newtons? So net force is equivalent to applied force. Okay, just by logic, we know that the answer would be 18, but still, let's show the computation. So net force is 8 newton, applied force is the unknown, frictional force is the 10 newton. Put this on the other side, plus 10 newton SF applied. 10 plus 8 is 18. Okay,